Hey everybody, welcome to Tech Tuesday. Today I'm going to be talking about Gap. I'm not talking about the clothing store. I'll be right back. Thanks for joining me for Tech Tuesday. So my name is Rick Uzzi here with Zcorm. I do this every Tuesday at 3 o'clock. Thanks for joining me. So today I'm going to be talking about Gap, and specifically that would be the new standard enclosures that they're working on for cable operators. It's general access platform. We'll take a quick look at this. So general access platform. And the idea is that we want to have these kind of standardized nodes out there so we don't have to have a whole bunch of different nodes from a bunch of different manufacturers. So there's different benefits to this. So let's go ahead and show some slides. Get some other ones going here. There we go. So this is kind of your typical node deployment that you might see today, where you've got different kinds of maybe access nodes out there in the field. You've got here small cells, so something like a 5G deployment. RPD, so a remote PHY deployment with your RPD device out there, your remote PHY device. Then maybe a remote OLT. So you've got these different nodes that are out there in the field, and as cable operators are kind of driving deeper into the plant, fiber deep into the network, the number of these fiber nodes are really expanding, and they're increasing out there. So, and again, you might have these different types of nodes where you've got different types of access methods from different vendors, maybe some of these all hanging on the same piece of cable out there, so it's not very efficient. And having these different nodes means having to inventory these different types of nodes and have different pieces of that in your inventory. Then if you're going to change technologies, right? So if you want to change to a new access type or something like that, you've got to then swap out an entire HFC node. You've got to basically splice in an entirely new node housing into your plant right there. So that's obviously going to be disruptive and costly and time consuming. So this is what they're trying to get away from with this idea of a GAP, general access platform. So what is that? So this is a standards-based housing. The idea of the standard is to make the standard housing that's standard as far as physical, thermal, mechanical, and electrical properties. So you've got this housing then that's standard that then you don't need to worry about reproducing and making all of the time. So this started back in 2018, in the spring of 2018. There's a SCTE working group working on this. So they're coming up with these standards for this enclosure. So this is going to allow operators to deploy these multiple technologies into the same housing. So DOCSIS, PON, wireless, they can deploy multiple items in the same housing and not have to worry about different vendors, those kinds of things. They don't have to support and inventory different types of custom enclosures in their network. It could be the last housing that they ever put in a particular place because it'll be flexible and it's expandable. So it's kind of future-proof in a way, because you're not sitting there with this housing that's supporting a technology that could be out of date at some time of the point or something that you're going to swap out. You've got this housing out there that you can then flexibly change out the capabilities or add capabilities in the future. And this is important because it's kind of hard for manufacturers, because they've got to, as they come out with new technologies, they've got to design the housing and all of those properties, your thermal, electrical, mechanical, physical kind of properties. They've got to design that so that everything fits and is going to work with what the cable operators need. So it's just an extra thing that they've got to do, and that's not really their specialty a lot of times. Their specialty is going to be what's going into the housing. So they don't need to worry about that now. They can just focus in on what they do well, which is developing the innovative applications that are going to be inside the housing that are going to be driving the technology. So that's a nice benefit there. So it's modular, plug and play, different application modules can be put in the standard housing, and then again it's going to allow for multiple types of access, different types of technologies in the field, all on the standard platform. So this is an example of a slide that was at the SCTE show last fall. Remember when we used to have shows? I know I'm dating myself here because it seems like it's 15 years ago. Maybe it's really not that long. But anyway, so when they used to have shows physically, this was a slide in one of the presentations. So you can see here that the way they're looking at it is the lid is the intelligent half. That's where your application modules will generally go. A couple of different backplane options, high and low speed, and then you've got the base, was going to be where your power is. I think also maybe the compute module is in the base. I'm not sure if that's showing that here, but you've got these two different halves, and both are really, they're wanting both to be modules, so that you've got your housing and these modules go in there, and as long as the modules support the standards of the housing, then everything will work just fine. Doesn't matter if you've got different vendors, doesn't matter if you've got different types of technology in the same housing. They all just plug into this housing, and then everything works together in conjunction with that because there's a standard that they're working around. So it's going to allow different delivery of multiple services in a single node. That's important. It's going to facilitate the migration to edge computing. So again, as we push things out to the edge with distributed access architecture and NFV, this is going to help with that. It's going to reduce inventory for cable operators, so they don't need to, they've got different kinds of applications that they want to deploy out there. They don't need to have a specific custom node enclosure for each one of these things. They can just have the gap enclosure, and then they get the different modules and plug those in. So they can use these different solutions from different vendors too. So that's another thing, is they're not locked into one manufacturer per node. They can mix multiple manufacturers within that same node, again, as long as they're all supporting the standard. So it's kind of exciting. This is also from that same presentation. So this is just showing what a prototype looked like. At the show last year, they actually built, these companies that you see at the bottom here, actually put together a prototype enclosure. It was not a production model, and they kind of basically used off-the-shelf stuff, but they made a prototype of this gap enclosure. In this case, it was for a remote PHY kind of application, and that's probably going to be the first application that you're going to see on this. That's kind of the lowest hanging fruit, as a lot of operators want to extend out into the network with remote PHY or remote MAC-PHY. Then these enclosures can be used for that. So you've got the standard out there, and then you can have the manufacturers developing the RPDs and the remote PHY devices as well, remote MAC-PHY devices out there as well to the standard, and then you've got this standard enclosure out there. Other applications could be CBRS. That's a hot topic right now. CBRS, Citizens Band Radio Service for wireless, 5G, remote OLT. So again, you can have, there's a lot of innovation available here. Once you have this enclosure, then you've got the manufacturers that can start thinking about the kinds of things that they can put in this enclosure, and they'll be developing those modules for these different kinds of applications. So that's kind of nice. And I was just thinking earlier, maybe there could be some kind of a diagnostics module that could go in there that could do some kind of diagnostics out there at the edge. So you can see here the way that it's set up with the, in this case, they've got the RPD module for the remote PHY, and you've got your backplane in there. At the top, you've got the power supplies, distribution, and some modules there. And then you've got your compute module down at the bottom, the Intel compute module in this particular prototype that they built. So when, it sounds exciting, I'm sure, for cable operators, because again, this is going to save them. You think about the time and money this can save, and just the fact that if you put an enclosure out there and then you're going to change something up, you don't need to rip it out and put something else in. So this is something that I'm sure the industry is looking forward to. So what are we looking at here as far as a time frame? So the standard, they're saying, should be completed about early 2021. And that's looking like it's on track from a presentation I saw just last week on this. So it looks like that's still going to be the case. They're hoping to develop the enclosures at that point. Obviously, then you'll have some manufacturers that will develop the actual enclosures, the physical enclosures. You'll have some that will develop just the modules. You may have some that will do both, but again, people will probably specialize in what they're good at. Whether that's the physical properties and the standard of the enclosure or the modules that are going to be driving the technology within it. So they're going to start probably developing the enclosures and the hardware and the software for the modules probably in 2021, to the point where the first nodes will be ready in 2022. So this should have a big impact, again, for cable operators. I'm sure that you'll start to see them want to implement this pretty quickly as they move forward, because this way, the more of these they get in their cable plant, if they can hold off putting stuff out there, the more of these they get in their cable plant, then they know that they're kind of future-proof there, and they don't need to be changing out whole nodes in the future. So that's it. I wanted to give just a high-level view of what this gap is today, what we know about it, because I know a lot of people are going to be interested in this. If you have any thoughts on this, feel free to just leave a comment on the video. Hope this was helpful. You can go ahead and subscribe to our channel. Just hit the little subscribe button down below the video, and if you do that, click the bell and you'll be notified. And then also, if you would, give it a thumbs up if this was helpful. So again, this is what a gap enclosure is all about. So again, I'm here every Tuesday, 3 o'clock. Hope to see you next week, next Tuesday at 3 o'clock for Tech Tuesday. Bye-bye.